Hello and welcome. This is the marking automation project presented by the SLIIT HCI research group and the e-learning and education research group of Faculty of Computing. My name is Shyam and I am the group chair of SLIIT HCI. First, let me introduce my team. As you can see, we have a number of staff members involved on this project. We have members ranging from heads of departments, senior lecturers, assistant lecturers and instructors. We are a very vibrant team who have put a lot of hours and a lot of research work into this project. Now let's look at the problem that we are trying to solve. Now, as we know, in SLIIT, we have thousands of students, and these thousands of students take a number of programming modules every semester. And within one programming module, we have a number of assignments. So this results in thousands and thousands of student submissions, programming submissions. We have calculated that we spend about 11,000 hours per semester just marking these programming assignments. These are all done by human beings at the moment. So this number can only become higher, especially with this technological era, with the COVID-19 pandemic, and also the tendency for more students to follow IT and programming, computing degrees. This number can only grow exponentially. And this is true for Sri Lanka as well as the rest of the world. Now the solution. The solution is, instead of marking these assignments with 100% human involvement, it is to develop a tool that automates the grading. And a tool that can lead to research publications, because automatic grading involves a number of research areas that need to be addressed in order to come up with an accurate auto grading tool. We need to support many programming languages, and moreover, this auto grading tool has to be user friendly. If not, academics will not use it, and it has to have a minimal learning curve. We have calculated, based on the hourly rate of our marking staff, that we could save 2,750,000 Sri Lankan rupees per semester. Now let's look at the methodology. How can we achieve this? So first of all, we need to provide a way for the lecturer or the assignment setter to provide the marking scheme into the system. So the auto grader knows how to mark. Therefore, we plan to develop a domain-specific programming language to do this. And then the next step is, based on this proposed domain-specific language, we develop a user-friendly auto-grading software that will run and simply grade all the student submissions. And then the last step is to evaluate the proposed language and the tools. The language has to be user-friendly so that the lecturer can input the marking scheme into the system without much difficulty, and the tool has to be user-friendly so that it's customizable, configurable and understandable. Next, we will look at the architecture. So the architecture is basically, as I explained before, the marking scheme written by the domain-specific language or DSL is fed into the system. This is provided by the lecturer. And then the student submissions can come from our learning management system or course web, which will be also fed into the system. These are provided by students. So once these inputs are fed into the system, the auto grader will produce a results table which will show what mark the student has got for their submissions. So this is the very simple plan which we plan to achieve, but the path might be difficult. In addition to the auto grader, we also develop some cleanup scripts. So these cleanup scripts are made to make the lecturer's life easier. So we develop code that saves time by automating many steps in the marking process. For example, once you download all the student submissions from CourseWeb, you can remove unwanted files automatically. You can organize the code, images and reports into different folders for easy marking and traversal. And then you could merge multiple code files together so that you don't have to open and close different files when marking. Even after the autograder is introduced, these can be used to audit and double check the autograder's results. And we have calculated that there's an 80% reduction in overhead tasks by using these cleanup scripts. Since we use the agile methodology, we use a Kanban board, namely Trello, to manage our tasks. Now, since we are all lecturers and academic staff and we have teaching duties, we work on this project in our spare time. And therefore, to work asynchronously and also to communicate with each other over online means, we use this Trello board as shown on screen. Furthermore, we have identified a number of research areas which can be addressed by this project. For example, domain-specific languages, static code analysis, software quality metrics, machine learning, deep learning, and graph convoluted neural networks. So, in addition to the contribution to SLIIT, we can have a number of publications in various conferences and journals as a result of this project. And this is the output. So as you can see here, we have a user interface which has auto grade, manual grade and edit grades options. And then this is a preview of the code that we use to write the autograder, and this is a preview of the result. So as you can see, this autograder, this sample runs a student submission against a number of test cases and gives us a direct indication of how many test cases have failed and how many test cases have passed. And also it generates some summary statistics here to show us that how many submissions failed compilation, how many submissions timed out, and how many submissions had invalid outputs, and how many actually gave the correct output. And all of this has executed in about 4 seconds. This sample involves about 47 submissions. So as you can see, 47 submissions to be graded by human beings would take a lot longer. This is the best proof of concept that we can show, which indicates that a lot of human hours can be saved. Another outcome from this project is the start of a Master of Philosophy by one of our own staff members, Miss Janani Tharmasila, who is supervised by myself, Dr. Kalpani Manatunga, and Dr. Darshana Kasturiratna. Another outcome are publications. So we have 2 publications accepted at international conferences as a result of this project. The first ones of these is the revisit of automated marking techniques for programming assignments. The authors are Ms. Janani, Dr. Kalpani, myself, Dr. Darshana, and Ms. Tarsika. The conference we published is EduCon 2021, which has a H-index of 22. The second publication is source code based approaches to automate marking in programming assignments. The authors are Ms. Tilmi, Ms. Janani, myself, Dr. Kalpani, Dr. Nuwan, Ms. Chamari, Mr. Udara, Ms. Tilini, and Ms. Dilani. The conference that we published was CS-EDU 2021, which has an H-index of 12. We have a few publications planned for the future. The first one is designing this domain-specific language and the compiler and the language evaluation details to be published in a programming languages conference such as PLDI. And the second is actually running this autograder in one of the large modules at SLIIT and publishing a paper focusing on the real case studies. For example, the first and second year programming modules such as C++ and Java. Finally, let's come to the impact. Now, students can benefit from this system. They can receive immediate feedback for their submissions without having to wait for staff members to return it after a few weeks. They can get immediate and accurate feedback for their submissions which don't differ from staff member to staff member. They can use this software as their own personal tutor as they work by themselves on their assignments. They can get a real-time learning experience without having to wait for their scheduled lectures and labs. Then impact for academics is even more. Efficient marking. The academic only needs to set the marking scheme and let the software do the rest. Consistency in marking is another problem, especially in large teams where a lecturer has to manage a number of instructors and has to manage consistency in marking between all of them. The software will manage the consistency seamless. And then this also tries to reduce need for post-marking moderation. Definitely better utilization of human hours is an added benefit. This time could be spent doing more research. And most importantly, it eliminates favoritism and bias. This project will also open up so many opportunities for new research in the fields of machine learning, software metrics, code quality, and so on and so forth. So there's a number of impact factors for academics as well as students. So that's all for today from the Marking Automation team. On behalf of the Human-Computer Interaction Group and E-Learning and Education Group of Faculty of Computing, we would like to thank the Research Committee of the Faculty of Computing for giving us this opportunity. Thank you very much.